Right, good morning grade 11s. It's Thursday 11 of June. We are now still with general solutions, but now we're going to do general solutions using trig identities today. Okay, so what must I remember? Okay, the first thing is you can only solve an equation. This comes from algebra. You can only solve an equation if you have one variable in this equation. In this case, you can only solve a trig equation if you are working with one ratio, meaning you can't work with sine and cos in one equation to solve it. Okay, what is the second thing I need to remember? What are my identities? I know that the first one, tan theta, can be sine theta over cos theta. And the second one there, I know that sine squared theta plus cos squared theta is equal to 1. And I can rearrange that equation so that I isolate sine and I isolate cos. Okay. Now solve means I need to determine values for theta within restrictions. We saw that in the previous exercise as well. If I say determine theta, then I just find out the general solution. If I say solve, it means I have to go find values for k that falls in that restriction. Okay, so there are different ways of solving equations. Now we have to think about what we did in algebra. Is we can have linear equations, okay, and I'm going to show you one just now of linear equations. I can have quadratic equations. Now, what are the different ways I had to deal with quadratic equations in algebra? Get one side equal to 0, then factorize. What can I factorize, or how can I factorize? Take out a common factor, factorize a trinomial or difference between squares. Okay. The third step we're adding to trig equations is solve the angle by using general solutions. Okay. The third one, which is the difficult one that you're going to have to look out for, is using co-functions or co-ratios. But that we'll only do on Friday. That's a whole lesson by itself. Okay, so if I look at this example, the first example is an example of linear equations. So when I do linear equations, I'm going to ask you, solve sine theta equals to 3 cos theta, so solve for theta between 0 and 360. My problem is that I have an equation and I have two ratios in there. I've got a sine and I have a cos. Not one of them are squared, so I can't use the quadratic identity in there. I do, however, see that if I divide both sides by cos theta, I am able to get 3 alone on the right-hand side. By doing that, I also managed to go from 2 ratios to 1 ratio, because sine theta over cos theta is tan of theta. Right. So what does that mean? That means that I can find my general solution. So I can say theta is the shift of tan of 3. And what do I know about the general solution? I know it's plus k times 180, while k is part of integers. Okay, so using my calculator, I am now going to say shift tan 3, I get theta then is 71,6 plus k times 180. I have to work between 0 and 360. So I know if I make k 0, theta is going to be 71.6. I'm happy with that. If I make k negative 1, I will have 71.6 minus 180. That is going to give me negative 108,4 that I may not use. So I'm going to go to k as 1. So if I have 71.6 plus 180, I get theta is 251.6. So those two are cool. They are in my range. The moment I make k2, I'm going to be outside. So theta is equal to 71,6, or theta is 251,6 degrees. That is an example of a linear equation. Okay. So if I look at the next example that I've given you, I am saying to you, determine the general solution of 2 sine theta tan theta minus tan theta equals 0. I have an equation. My problem is I have two ratios in there. I cannot solve an equation if I have two ratios in there. I do notice a 2 term on the left, and in each term I have a tan alpha. Okay, which means I can take out a common factor. So tan of alpha is 2 sine theta minus 1 equals 0. Okay, so what does that mean? That means that tan alpha is equal to 0, or 2 sine alpha minus 1 equals 0. So now I have two scenarios that I have to work with. Okay, so alpha is going to be shift of tan of 0 plus k times 180, and k is part of integers. Now if you don't know this, tan 0, thinking of my graph, is where? At 0. So alpha is 0 plus k times 180. Or, now I have to isolate. So first I'm going to move the minus 1 over. So I'm going to have 2 sine alpha equals 1. Now I'm going to divide both sides by 2. So I get sine is a half. What does that mean? That means writing the general solution for sine, I will need two options. I will have the reference angle, which is received or worked out by the shift of sine of a half plus k times 360, and k is part of integers, or I will have 180 minus the reference angle plus k times 360, and k is part of integers. So shift sine of a half is 30 degrees. If you did not know that, your calculator is there to assist. Okay, so 180 minus 30, theta is 150 plus k times 360. Okay, and that was determine. It's not solve. So determine, don't substitute values for k. Right, let's look at another one. So if I have cos squared x plus sine x equals 1, what am I doing here? I am only allowed to work with an equation if I have one ratio. Do you notice that cos squared x is jumping at me? Because I know from my identities that I can write cos squared x as 1 minus sine x squared plus sine x equals 1. So the brackets is not necessary, but I can just take them out, and then I will have this plus 1 equals 1. Okay, if I move everything to the right hand side, I will have sine squared x minus sine x, and the 1 will cancel each other out. So this is not a trinomial, but I can take out a common factor. So I have sine x as a common factor. I'm left with sine x minus 1. What does that mean? I have two options. Sine x is equal to 0 or sine x minus 1 is equal to 0. So each one will have to go the general solution route. So here I will have x will be equal to, if you don't know, if you're not sure, you work it out on your calculator, people. But on my sine graph, I start at 0 and 0. So x is 0 plus k times 360. K must equal, or k is part of the integers. And my second general solution is 180 minus my reference angle. So 180 minus 0 is 180, and that's the option for my first. Okay, the second part there, I will isolate sine x equal to 1. That means my first general solution, x is going to be shift sine of 1 plus k times 360, and k is part of integers. Once again, if you're not sure, use your calculator. So look at this. What's going to happen here? 90 degrees. Okay, why that? Because I know at 90 my graph peaks at 1. Okay, plus k times 360, and my second part of my general solution is 180 minus 90, and that is 90 plus k times 360. Right, so that was your homework. Well, that was the examples. So let's look at your homework. I have to make some alternate suggestions here because I have done some of this work with you now. So you are going to do number 1E. I'm going to let you do. I will update the online. When we do the online, number 1, you're going to do B, C, you're going to do D and E. So leave out A. Then you are going to do number I as well. And that's all for today. Okay, 1, B, C, D, E, and I. Leave out A. It was done as an example. Thank you.